Hello, and welcome to Los Alamos National Laboratory's Math and Science Academy. In this thread, we'll be exploring the Grade 5 Common Core standard that deals with multiplication of fractions by using visual fraction models or equations to represent the problem. Okay, our learning goals in this problem include the following. The student needs to be able to accurately translate word problems into the appropriate mathematical question. And at the end, be sure to answer the question that the problem poses. The student needs to be able to understand finding a benchmark percentage of a whole number. By benchmark percentage, we mean one that translates into a nice simple fraction. The student will be working with percentages both as fractions and as decimals, which extends the standard out a little bit because the standard itself doesn't include decimals, but we'll introduce it to show the relationship between decimals and fractions. The student will be able to use multiple strategies, area models, number lines, and procedural symbols to calculate percentages of whole numbers. And finally, the student will communicate mathematical thinking with precision. Okay, so here's our problem. There are 50 students in the 5th grade at Taos Elementary School. One day, 20% of them were absent. Use a mathematical model to determine how many 5th graders were in school that day. So a few things to notice. We're using a whole number of students to make things simpler as we start off. We're using a percentage that's easily converted to a fraction. I'll call it a benchmark percentage. And the other thing to note is that the question asks how many students were in school that day. Well, the information that's given is the number of students that were absent. So there's kind of a hidden operation that the students need to understand and identify. We'll begin with an area model by representing the whole class as a circle. This represents 50 students, or 100% of the class. You'll notice that we've written the words here, 50 students and 100% of the class, to help the students stay in touch with the meanings of these different numbers. So the next step is to look at, well, what's 20% of the class, because those were the ones who were absent. And so 20% of the class is what we're after. And the students' understanding of percent at this point, hopefully they'll be able to know that this is 20% is 20 out of 100, or per 100, which as a fraction is written this way and can be converted to 1/5 of the class. So now we know the fraction of the class. We can represent that graphically by shading in 1/5 out of the pi. The question is, how many students does this represent? And hopefully students understand that 1/5 of 50 students is 10 students. How they get to this will depend on the level of the student. It may be obvious, or they can take the 50 students, break them into groups, even groups of 5 groups of an even number each, and they'll find that that answer is 10 students. So now we know that 10 students are the ones who are absent. Often students will stop at this point, but it's important to remind them about the question. The question is how many 5th graders were in school, and so they need to do the next step, which is to recognize that the students who are in school are the whole amount, 50 minus 10, and so 50 minus the 10 students who are absent leaves us 40 students who are present. Okay, so here's our problem again. We have 50 students in a classroom. One day 20% of them are absent, and the question is how many were in school that day. In this formulation of the problem, we're going to use a double number line. This linear representation of the whole is a little bit more abstract than the circle in the previous example. The circle relates directly to a pie or to a pizza or something physical, whereas the line doesn't do that quite so readily. So this may be a little bit more difficult to grasp, but hopefully not too bad. At any rate, we represent the whole as a linear bar that represents 100% or the whole of something. This can be anything at this point. And we're interested in what 20% of this is. And so to do that, we break the whole into even sizes and scale a scale so that we can find where 20% is. Now we could have broken this just into 20% pieces, but I chose to break it into 10% pieces to make it a little bit more general and help the student recognize that it's not imperative that you break it into the pieces that are given in the problem. For example, if the percentage in the problem was 17, you wouldn't want to break this into 17% pieces. So that's the idea there. 20% then of this is represented by 2 of these units that I broke it into. If the student happens to notice that this is 1/5, that's great, but it's not necessary. Really just need to notice that it's 20 out of 100. And so now the question is, how do we translate this percentage into a number of students? And to do that, we're going to represent the number of students as a bar of equal length, 0 to 50. And there's a correspondence between these two bars because 20% of this number of students is going to be located, if you're thinking of a number line, at the same place where 20% occurs on the percentage number line. So really we're trying to get the student to see this key idea that to find 20% of some number, we simply need to line up 2 bars that are the same length, and on one of them represent percentages, one of them represent the number of items you have, in this case 50, and then look for where the corresponding point is. So to do that, we'll break this 50 bar into pieces that make sense, and in this case breaking it into 5s makes sense because it corresponds to the partitions that we used in the percentage number line. And then from this pattern, hopefully students can see quite readily that the number they're looking for, which represents 20% of 50, is this number 10. So that's the concept behind it, and now they recognize that 10 students are absent, need to go back and look at the problem and recognize that the question is how many are present. To do that, we'll subtract the 10 absent from the 50 total and get that 40 students are present. Once again, okay, so here's our problem again. We have 50 students. One day 20% of them are absent, and we're trying to find the number in school that day. So we'll begin this time with a procedure. Procedures are the most efficient, but they're also the most abstract, and so they should be the last things to be introduced. Preceding that, we need to work with images and concepts as we've done in the earlier examples. So when we're using a procedure, we need to find the key concept in the problem. In this problem, the key mathematical idea is that we need to find 20% of 50. In this case, 50 students. But the math is 20% of 50. The other thing to notice is that in mathematics, the word of, which we see up here, is represented by a multiply. So there are multiple ways to do this. The first way is to notice that 20% is literally 20 out of 100%. So 20 100ths times 50, we go back to some facts we've learned regarding multiplication of fractions and whole numbers. There's an implicit 1 in the denominator here, and we multiply numerators and denominators to get 20 times 50 in the numerator, 100 times 1, this implicit 1 that's invisible here, to get the denominator of 100. And that leaves us with 1,000 over 100, and then various ways of reducing fractions or dividing. We can end up with our answer, 10 students. This isn't the answer to the problem. It's important to know that, but it's the result we need. Another way to do this percentage multiply is recognizing the relationship between percentages and fractions. 20/100ths is 1/5, and if students are comfortable with fractions and they know them well, they'll recognize that quite quickly. And in that case, we can think of 1/5 of 50, not even working with a multiply, but rather thinking of it as a divide. 50 divided into 5 pieces or 5 equal parts, and get 10. So it depends on what students are comfortable with. In any case, this method is a little bit more, can be a little bit more confusing. It depends on how comfortable they are with fractions. The final way is to look at 20/100ths as a decimal. This is probably the most abstract. And then we can multiply using a procedure for multiplication, 0.2 times 50, and we get 10. So we've now done the core math of the problem, and the final issue is to make sure that students recognize that the question isn't asking for the number 10, it's asking for the number of students present, and so that would be 50 minus 10, or 40 students that are present. So we've looked at this same problem using approaches that are strong on image, strong on concept, and ultimately strong on procedure. And that's usually the progression that you want to use, from images and concepts through to procedures. Next, we'll look at some mathematical writing that we'd like to see students achieve in this kind of a problem. So now let's take a look at the mathematical writing that we'd like to be able to get ultimately for a student who really understands this idea. They start off with a diagram here representing the whole, 50 students total, and shade out the part of it that is 20%, recognizing that they need 20%. Here's a core idea. 20% of something is 1/5 of it, and the recognition that they need 1/5 of 50, the core mathematical idea in the problem. How they get that is a procedure here. 1/5 of 50 is 10, and they can do it in multiple ways. So 10 students are absent, and ultimately they're recognizing that they need to answer the problem, which requires that they subtract 10 from 50 and have 40 students that are present. You'll notice that they've used images, they've used concepts, shown concepts, they've got some facts here. 20% of something is 1/5, and really have focused on language. That's what this does, is really helps the student to communicate well, not necessarily with mathematical language, although it's important that the math language be correct, but just with everyday language to describe the ideas that they're going through their head as they solve the problem here.